Hello all, and welcome to preparing 3D models for STK using the free open source software Blender. My name is Lucas Tomervik, and I am a technical support engineer here at AGI, which is now a part of Synopsys. And I'm joined by my colleague here, who is an intern this summer with us, Emma Green.
Hi.
So let's go ahead and jump right in. What we see here on the screen is a 3D model of a drone that I had made for an internal training for one of my colleagues. And, you might be coming into this video with no 3D model. If that's the case, there's tons of resources online. Whether that means you want to build your own 3D model, or perhaps you're just looking for a 3D model that someone else has built. Regardless, there's tons of sources online. A lot of times people will come to me with CAD models that are not necessarily optimized for STK. And in that case, you can either use retopology, which is a process of recreating the mesh with more optimized geometry. Or you can use something called the decimate modifier. And the decimate modifier is found in Blender right over here on the right side under this wrench icon. When you go to the wrench icon, you can click Add Modifier. And under Generate Decimate, you will enable the ability to reduce the geometry of your 3D model. You can change the ratio down from the original count to, say, 1/10. And when you do so, your 3D model will then have 1/10 of the geometry that it previously had. Now, it doesn't get rid of or reduce the geometry in a very efficient manner, so you're going to have a pretty messy mesh, which can mess up textures and shading. But if all you really care about is getting your model into STK and have it be optimized for STK, using the decimate modifier is perfectly acceptable. But if you want a nice looking model like this, you do have to take care to pay attention to the underlying mesh. Regardless, once you have your 3D model, before we go into VS Code in a second, to prepare the model in Blender, the most important things to know are the orientation of the model and separating the model into multiple objects. So, for instance, if we want these propellers to spin independent of the body of the drone, we have to make sure that the propellers themselves are separate objects. So I've already done that step, so you can see when I rotate this propeller, it is a completely separate object from the body of the drone. And that's important for when we go into VS Code in a second. And as I said, the other thing is the orientation of the model. So right now, this model is oriented correctly, but for instance, if I were to rotate this by 45 degrees, and we take a look at the local axes of this object, we can see that the z-axis is actually correct. It's still going normal to the top of the drone, which is how we had it set up in the first place. Now, if I go back 45 degrees like I had it, and I apply this rotation, which is done via Control and A, and then I try and rotate the object along its z-axis, you can see now that the z-axis goes to where the global z-axis is. And when we try and rotate this object along its z, it's at this weird, funky angle. And this is just kind of more of an abstract example, but where this really comes in important is, for instance, like a flap or an aileron on an airplane. If you have the local orientation of the flap set to the world axes, then you're going to get that weird funky rotation we just saw. Versus if its orientation is correct locally, you'll have the correct motion of the flap. So yeah, with all that said, your 3D model is prepared and ready to go into STK, and now we're wanting to add articulations to the model. So what we need to do is export it from Blender first. So what we can do is select all of the objects by pressing the A key. And then if I come up here to File, Export, we want to choose GLB/GLTF, as that is the best model type for STK. And in the exporter, the things to take note of are the Include dropdown. I like to choose selected objects, and that's just going to export everything that we've selected in the 3D view, which can be important if you have like variations of a 3D model, and you wanted to export different parts of the mesh at different times or for different purposes. This transform dropdown will affect the orientation of the object, because the orientation in Blender is different than the orientation in STK. And changing this toggle will change how those orientations are translated from Blender to STK. I generally leave the +Y up toggle on, but you're welcome to turn it off. And the last one is this animation dropdown. The data dropdown is not important for what we're trying to do. The animation dropdown, you just want to ensure that this is set to actions, and that'll be important in a later video. So once that is done, we can export our 3D model. I'm going to call this Aurelia Video. And I'm going to go ahead and place it in the 3D model video folder. Once that's exported, we can come into our directory where we placed it, go find it down here, and we want to open this with VS Code. So we can right-click and choose Open with Code. Obviously, you'll need to have VS Code downloaded. When I open this with VS Code, you'll see this blank screen, considering that the file is a GLB. The B stands for binary, so it is not currently in a human-readable format, so we need to get it that way. To do so, we're going to need to enable 2 extensions in VS Code. So we'll come over here to the left side of our screen. We'll select Extensions, and we want to enable 2 extensions. So first is called GLTF Tools. You can type that in, and when you open it up, yours is going to say something like Install or Enable, and you can install this add-on. Once that add-on has been installed, you might have seen a sneak preview when I first opened up the extensions, but we want STK GMDF Tools as the other extension. We can click on that, and you go ahead and install that extension as well. Once you have those 2 extensions installed, we'll come back to the GLB that we opened up. We're going to right-click on the tab. Right-click on the tab. We're going to come down to GLTF Import from GLB. And it's going to ask you where you want to save it. You can save it in the same directory or wherever you want. And you'll see once I open up the GLTF, we have the same exact 3D model, but now it's in a human-readable format, and you can see all the code that makes up that 3D model that we were just looking at. You can see this is about 6,000 lines or so it's a lot of information. Now, in order to get the STK specific information into the 3D model, we want to make another file called the GMDF file. And to do so, we're going to come up to File, New File. We can type in GMDF, hit Enter. It's going to open up the File Explorer again. And you want to go ahead and name this file such that it has the same exact name as your GLTF file. So let's bring this down so we can look. We want to name it Aurelia_video. And the reason is when we later go to inject this information into the GLTF file, the STK specific information, the tool is not going to work unless the two files have the same exact name. The tool is going to look for that GMDF file with the same name, and if it can't find it, it's going to throw an error. So we'll go ahead and create the GMDF file. And you can see it opens up this blank file.
So, Lucas, why do you need a GMDF? Can't you just edit directly in the GLTF?
You can, yes. You can edit directly in the GLTF if you want to. The reason for the GMDF is largely organizational. It just keeps all the SDK specific stuff in a completely separate file, so you don't get confused, am I changing something for SDK or am I altering the 3D model? Beyond that, though, it's largely about syntax. If you're editing the file or the GLTF directly, you have to figure out where all these lines of code go in this 6,000 line file. Versus a GMDF, the structure is pretty generic. It's going to be the same almost every time with like little variations. So the GMDF is just easier to create, and when you use that inject command, it will place those files in the place those lines of code in the 6,000 lines in the correct spot. Yes, now we have the blank GMDF file, and in the name of time, I'm going to go ahead and close this and open up a pre-prepared GMDF file. So in the GMDF file, there's at first glance seemingly a lot going on, but it's pretty straightforward once you learn what everything is. So for this video, we're only focusing on articulations. So we're focusing on this articulations block, which is right now literally the entire file. Now, in later videos, we're going to see different blocks. We're going to see metadata blocks, and we're going to see, model pointing, attach points, solar panels. There's going to be a lot more information in this file. But for now, we're just focused on articulations. So in the in the GMDF file, under articulations, your first line of code is going to be this name block. And I'm actually going to go ahead and open up this this model in STK Model Viewer, which comes pre-installed with any install of STK as a side software. That you can find by searching up STK model, and it should show up. Once we open up STK model viewer, we're going to see the 3D model in the same render engine as STK uses. And the only functionality of this little software is to view a 3D model and its articulations, which is very useful for quick iteration. So if I change this to land and sky, just so we can see what's going on a little bit easier, we can see that these articulations that have already been created are here in STK Model Viewer. So I'm going to hop back and forth between these just to kind of explain what's going on. We can see that name block, Aurelia, is what is going to show up when you're looking for articulations before you start actually articulating the mesh itself. So like if we had 3 different articulations, maybe Aurelia, propellers, lights, you would go in and choose whichever one you're interested in, and that's where you define that in the name block right here, this first name block. Then under the Aurelia name, we can see that there are 1, 2, 3, 4, 5, 6, 7 different articulations, and these articulations for a given, I guess I should say, these transformations for a given articulation are defined under the stages block. And you can see there's like there's 7 different blocks, each corresponding to the different translations. So in each stage, you want to define name again, but as we see, that name corresponds to the name that shows up for the transformation rather than that shows up in the list of articulations. After name comes type, and type is just the type of translation that the given name is doing. So in this case, move X is Z translate, and the only reason X and Z don't match is because of the orientation differences that were mentioned earlier in the video. And then the other 3 values are pretty self-explanatory. So minimum value, maximum value, and initial value. We can see that move X here goes from -100 to 100, and it starts at 0. But we can move the model, or we can rotate it. So those are all your basic translations that you can do to any given model. Now, the last important part for the articulations block is this model nodes block right here. And all this model nodes block is doing is telling STK which mesh in the 3D model these translations should apply to. So if we go back to Blender really quickly, we can see that the main piece of this 3D model is called body_LP. And much like the articulations, if I move this model around, you can see that the entire model moves with it, or if I rotate it, you can see the entire model rotates. However, if we want to isolate one single part of the model, so for instance, these propellers, well, when I rotate the propeller, what part am I actually rotating? I can see up here on the left, I'm rotating rotor FR_LP. So if I want to go in now back to VS Code and actually add articulations to rotate the propellers, well, we can do that. So I'm going to create a brand new articulation. So whenever you want to add a new line to a GMDF file, you can hit Control Space, and VS Code will try and guess what line you're creating next. And, a lot of times you'll have this where it's only one choice and it's just a curly bracket or braces or something like that. So if I hit Enter and Control and Space, you can see, well, now I have a bunch more options. Well, what are we trying to do? We're trying to make an articulation, and we know we need to define the name of the articulation. And if we go back up to the first one, we can see, well, the first name is what the articulation is actually called. So if we go back here to 3D Model Viewer, we can see, well, this articulation was called Aurelia, so we want to move the propellers. Let's call this propellers. Then we want to actually define what translations are happening to this propeller articulation. So let's hit Control Space. We remember we need to define the stages, or alternatively, we need to define what translations are happening. I'm going to hit Control and Space again. Control and Space again. Okay, so now we need to define the name of the translation. So Well, there's only one direction that this propeller can rotate, so I'm not going to worry about which direction it is, and I'm just going to call this rotate. I need to define the type of rotation, and we saw that we wanted to rotate along the local z-axis of this propeller. So, and if we remember correctly, the orientation differences between Blender and STK, we can see that a Z rotation is going to be a Y for STK. So we'll define that as Y rotate, and then we just need to give it a min, a max, and an initial value. Now we've defined the actual translation itself. So if we come out of stages and go to the next line, remember we need to actually tell STK what part of the mesh we are moving and giving that Y rotation to. So if we go back to Blender, well, we need to know what that propeller is called. So we've selected it, and as we pointed out earlier, it's called rotor FR_LP. So under model nodes, let's type rotor FR_LP. Now I'm going to save this file, and to get this information into the GLTF file, I'm going to go back to the GLTF file, and I'm going to hit F1, and I'm going to type in inject. And when I select inject, it's going to put nothing changed on the screen, but it's going to put all that information into the GLTF. I'm going to save the GLTF, and then I'm going to right click, come down to GLTF, export to GLB, and save that. And now we have a new GLB with the information and changes that we made.
So can I just use the GLTF and not worry about the GLB at all?
You can, yes. You don't have to do this last step, this right-click GLTF export to GLB step. You could just use the GLTF. Now, the main issue with that, and it's really more down to preference, but the main issue as I see it is if you're using the GLTF, you have to include all of the ancillary files in the same directory as the GLTF. So if we go look at our directory here, we can see, well, if I wanted to use this GLTF and STK, I would need to have all of these files that I've highlighted here in the same directory, or else STK either won't load the model correctly or it'll give it the incorrect texture and make it look wrong. But you're certainly free to do that. It's just when you're using a GLB, all that information is packed into a singular file so that you don't have to worry about that. And you can just use a single file, and if you have to give files to your colleague, you can just give them the one file. So it's a little bit more compact and less messy, in my view.
Gotcha.
So we've put that new propeller rotation into our model. So I'm going to reload this model. If I come over here to this little cube tab and File Explorer, we're working out of Aurelia Video. It's going to reload it. And if we come back to the articulations, we can see, hey, now we have a propeller rotation. And you can see that propeller over there rotating like we told it to. Now this is just one propeller, obviously. If we come back to the GMDF, the nice thing about this model nodes block is you can apply one translation to multiple meshes. So I could come in here and I could just type in rotor FLLP. And I'm just going to blaze through this real quick. I'm going to make the changes there and have them reflect in the file itself. We'll come in and we'll reload this model. And if we come back to the propellers articulation and rotate it, we can see, hey, now we have 2 propellers rotating. So I could go in and I could add all 6 propellers under this model nodes block. And because this one model nodes block applies to the propellers articulation, anytime we rotate, it's going to rotate anything that's under the model nodes block. So using these simple principles, you can fill out your GMDF file with many different articulations for basically every part of your 3D model. But that's all the time we have for this video. Join us next time when we talk about adding attach points, solar panels, model pointing, and I'll even go into STK itself and show how you can take advantage of 3D models and all these features that we're adding to the model inside of STK. Thank you.